Hi everyone, we're Team Marwell and we're really excited to present our project to all of you. So here's our team. I'm Zena, this is Alan and Seon. Our project has been overseen by Dave and Pete, and additionally we've had extensive support from both our technical and design mentors throughout the process. So I'd like to start by outlining the context of our project. So Marwell's mission is to conserve biodiversity and other natural resources on both a local and international scale, and they rely on the support of their customers to do so. Marwell are constantly seeking to encourage understanding and inspire care for the natural world, with the main aim of connecting people with nature. Now Alan will take you through the first problem that we encountered from our discussions with Marwell, and he'll also talk about our solution that solves this.
Thanks, Zena. I'd like to start off by introducing a character we've been working out throughout the course of our project, Mila. She's an 11-year-old Amur tiger, one of the two tigers at Marwell Zoo. Her family has recently been under serious threats of extinction, and there are many similar species that zoos like Marwell try to save. But when you're trying to take care of a captive animal, there's a significant need to ensure high quality of life within the enclosures. This is where our behaviorist Julie comes into the picture. She and her colleagues have helped look after the species by regularly monitoring their behaviors and looking out for anomalies and stress indicators. But monitoring these animals requires lots of time sitting outside while staring at the tiger for many hours to get a useful amount of data. At Marwell, they often spend over 90 minutes per day observing the animals, writing down what activities the tigers are doing, and then manually inputting the data into an Excel sheet. And interestingly, they have to do this manual monitoring task for all the animals in the zoo, not just the tigers. This is certainly not ideal for Julie or any of the staff, and this time can be better spent focusing on more important things. So, to improve the welfare of animals in Marwell and potentially zoos all around the world, we've created a solution where we're completely automating and even improving the behavior tracking task of animal experts and behaviorists. We've tracked behaviors of the animals and their locations using computer vision and created a dashboard which has all the information required to evaluate the quality of the lives of these animals and consequently give the zoos a chance to optimize it. Now let's assume Mila hurt her paw last week and she can't walk as she normally would. Before our solution, this would have only been identified a few weeks down the line when it could possibly be quite late. But now with our new solution, Julie can just glance through our web application to get more information of the tiger's well-being on a daily basis. So Julie visits the web app and browses through the dashboard. She sees something unusual in the highlight section of the page. Mila appears to have been walking significantly less and grooming much more than usual. So Julie wants to know more, so she navigates to the highlights page, where she sees a sharp dip in the daily walking hours on her right and a steady rise in the grooming just below that. And she's now fairly confident that something is wrong. She then investigates further by navigating to the activity data page, where she again sees a sharp rise in the resting hours and very less walking in the detailed activity timeline. Looking at the weekly timeline, it looks like something might have happened 3 days ago, which is causing this atypical behavior. She then has a look at the movement page and notices that Mila has been moving only in one part of the enclosure today and not very much more over the last week compared to the last month. She can now confirm that Mila might have an injury, looking at how less she's been moving. She can then call in the vet and download a report of the behaviors for further diagnosis, which could lead to a speedy recovery and a very happy Mila. So similar to this case, the web app can also help zoos spot high stress levels in the form of pacing and also spot major deviations from a typical day in the life of Mila. So now Zina will take you through another problem that we encountered from our discussions with the visitors at Marwell, and she'll also talk about our second product that solves it.
Thanks. So I'd like to introduce you all to Daisy. Daisy just turned 10 years old and she's excited for her birthday trip to Marwell Zoo. Her father John will be accompanying her and looks forward to an enjoyable and educative experience for both Daisy and himself. So after a long car journey, they arrive at the zoo, and their first stop, upon Daisy's eager request, is the tiger enclosure. When they get there, however, they can't seem to find the tigers. And after spending a whole hour thoroughly covering all 6 viewpoints trying to spot them, Daisy is growing increasingly annoyed and unfortunately faces the same experience after exploring the other enclosures within the zoo. This brings us to our first pain point. In the zoo's quest for exhibits that are super beneficial to animal welfare, Visitors are frustrated since they are often unable to spot the animals within densely planted large animal enclosures. Finally, both Daisy and her father grow tired of trying to find the animals and they decide it's time to depart. This leaves John concerned that Daisy had not learned anything about the animals that she could take away from the trip. And this brings us to our second pain point. Many visitors often leave the zoo lacking any understanding and empathy towards the animals, something that Marwell in particular desired to provide. So after taking a look at all of this, our team decided to have multiple screens planted around the enclosure, which constantly point visitors towards the best viewpoint for the highest chance of spotting the animals, while additionally displaying infographics that illustrate the behaviors of particular animals. And this enables a more personal connection between the visitors and the animals. So with our solution in place, let's take this story back again and look at Daisy and John's new journey. So on arriving at the enclosure, Daisy's attention is immediately drawn towards which viewpoint she should visit, and she heads over there with her father. Fortunately, she manages to spot the tiger immediately, and her trip at the zoo has already been a success in her eyes. Looking back at the screens planted outside the enclosure, she sees outside each viewpoint, she digests the infographics about Miller and facts about both tigers in the wild and in the zoo. These surprise her and motivate her to speak to a member of staff at Marwell to find out even more. So while Daisy learns more about the animals at the zoo, she starts to develop an emotional connection towards them and asks her father if she can adopt one. Since it's her birthday, John really can't say no. So both Daisy and John are really enjoying their experience, having the chance to not only spot the animals but also differentiate between them. And what's different about these screens compared to the usual screen one might find at an exhibit is that they update continually, displaying infographics associated with the current habits and behaviors of each animal, thus keeping both first-time and return visitors engaged on every visit to Marwell. So we've also developed an extensive set of infographic slides that would be updated on a regular basis so as not to bore any visitors, and we would switch between numerous options on each occasion. So Daisy leaves Marwell content that she got to see the animals and connect to them on an emotional level, and John is relieved that their experience was both engaging and educative at the same time. Now on to Seong to talk to you about the core technology that powers both of these solutions.
Thank you very much. So let's first summarize our whole system architecture. So firstly, the video goes through our three-step processing of detection, identification, and behavior classification. Then it's saved at the database in the cloud. Then the cloud function regularly runs to arrange the data in a format that is easier to be fed. And finally, the required data is queried and then fetched by the front-end web server to plot the graphs. So now, to make our applications provide insightful analytics from the video, our program had to be very smart and versatile enough to answer questions like, what is a tiger? What tiger is it? And what is it doing and where? And in order to make this happen effectively and efficiently, our team has used cutting-edge technologies such as machine learning and neural networks to our software so it can detect, differentiate, and know what it's doing. After days of training and improvements in algorithm, we managed to achieve an accuracy of up to 90%. So here are a few video examples of our backend software in action. So as you can see, it can detect the tigers very well. It can detect the behaviors such as standing, resting, and walking, and it knows which tiger it is. So once our powerful processor has finished the job of collecting the data, it'll automatically be sent to our database where our web application can pick up and show up on its graphs like this. So once again, in this video, our tiger Mila, she rests for 4 seconds, then she stands still for 2 seconds, and she walks away for 3 seconds. Now, how will this look on the web app and the database? So as you can see, when it's refreshed, first it records 4 seconds of resting. Then if you refresh again, it shows 2 seconds of standing. And then finally, if you refresh again, it records and shows 3 seconds of walking at last. So the same thing happens with the the visitor screen as well. In this example, we can see the other tiger, Bagai, in camera 4. So on the screen, it tells the visitors to go to viewpoint 4. However, once Bagay disappears from camera 4 and it appears again on camera 5 with some food in his mouth, then this update will be shown on the screen, and our Daisy and John knows exactly where to find them. There are a few functionalities that we intended to have, but we had to remove from our MVP, mainly due to time constraints. So let's talk about how our program can be improved. So first of all, now that it works on the videos that are directly taken from the zoo, the next step would be to permanently deploy the camera at the zoo. And secondly, we will capture many more different behaviors of tigers in order to provide much more valuable insights. Also, with the help of night vision cameras, our next step will be to track the behaviors at night, which we believe it'll add enormous value to our project. So we believe the scope of this project covers a much wider spectrum than we have touched within the last 3 months. So we believe the same technology can be applied to all the animals around the zoo. We believe with the collection of enough data, the computer can detect all the issues of animals at the earliest from the hint of very subtle anomaly from their behavior. So not only in the zoos, but also the technology can be applied to wildlife animals, where collection of big data in their natural habitat would benefit the research, and it can be utilized for conservation of biodiversity, which is a very big problem here. And then if this project was to be extended as far as it could reach, we strongly believe that it would have a significant impact in getting to know the animal and wildlife better. Thank you very much.
Thank you for listening et merci pour votre attention.